Hello everyone, welcome to another video. Today we are going to solve integral cos2x minus cos2 alpha divided by cos x minus cos alpha dx. Here alpha is a constant. As the first step, we can write cos2x and cos2 alpha term using double angle formula of cos2 theta. We know cos2 theta equal 2 cos squared theta minus 1. So we can write cos2x as 2 cos squared x minus 1 and cos2 alpha 2 cos squared alpha minus 1. Then we can remove the brackets in the numerator. Then we can write 2 cos squared x minus 1 minus 2 cos squared alpha plus 1. Then we can cancel out minus 1 and plus 1 in the numerator. Now we have in the numerator 2 cos squared x minus 2 cos squared alpha. Then we can get 2 as a common factor. Now cos squared x minus cos squared alpha, just like a squared minus b squared. A mean cos x, b mean cos alpha. We know a squared minus b squared equal a minus b into a plus b. So we can write cos squared x minus cos squared alpha as cos x minus cos alpha cos x plus cos alpha, just like a minus b into a plus b. Now we can cancel out cos x minus cos alpha term to the denominator cos x minus cos alpha term. Then we can write integral. We can get 2 as a constant value, so we can write 2 outside the integral. Now 2 integral within bracket cos x plus cos alpha. Now we can get integration sign separately. So we can write 2 integral cos x dx plus integral cos alpha dx. We know alpha is a constant, so cos alpha is a constant. So we can write cos alpha outside the integral. Then we can write integral cos x plus cos alpha into 1 dx. So we can get as the final answer 2 integration of cos x sin x plus integration of 1 equal x. So 2 sin x plus cos alpha into x is the final answer.